It is always recommended to do a reference search when you first power on your machine. From the main jog screen, press the reference key. You will notice that a menu appears prompting you with possible options. Press the cycle start button to continue the reference search on all axes. Press the escape key at any time to cancel. Another way of doing a reference search is to press the X key. Now press the reference key, followed by the cycle start button. This method allows you to reference search one axis at a time. You will need to repeat the process for all remaining axes. Now that machine reference is complete, let's review our demo part print, required machining operations, and tools needed to program the demo part we have selected for this video. Please note, in our demo, we will be working in inch units of measure only. We will refer to all dimensions as inches or thousandths of an inch when entering print data to the 8055 control. From our demo part print, you will see that we have a pattern of 4 drilled holes, one centered internal rectangular pocket, and one external custom profile. Now shown are the part dimensions and coordinates needed to program this demo part to completion. These are the selected tools we will use to produce the demo part. The tools are listed in the order that they will be used. Tool number 1 is a 1-inch diameter end mill, and we will be using this tool to surface mill our part surface. Tool number 6 is a 1/2-inch diameter spot drill, and we will be using this tool to spot drill all of our hole locations. Tool number 7 is a 1/2-inch diameter drill, and we will be using this tool to drill all of our hole locations. Tool number 2 is a 1/2-inch diameter end mill, and we will be using this tool to mill our outside profile and center pocket of the part. Our raw material size for this job is 6 inches by 6 inches by 1 inch aluminum. We will grip 1/8 inch of the bottom surface in our work vise so we can machine as many continuous steps without removal or flipping of the workpiece. After mounting the workpiece in a machine table vise, we will then establish our X and Y part 0 origin. In our demo, we will set the left rear corner as specified by our part print. After the X and Y part 0 has been established, we will then advance to the tool setup procedures. Tool 0 reference to the part surface and radius of the tool will need to be set. Once the machine setup has been completed, we will begin our programming for the first operation and then machine that operation to completion. Shown here is the surface milling operation. Our selected tool for this operation is tool number 1. We will use a 1-inch diameter end mill to remove a small finished cut of material from the top surface. This will produce a clean, parallel, flat surface needed for continued tool calibrations and part measurements. When completed, we will establish the remaining Tool 0 references to this new part surface that has just been machined. In our second operation, We'll be spot drilling holes to precision pattern locations. Our selected tool for this operation is tool number 6. We will use a 1/2 inch diameter spot drill to drill 5 shallow holes. Note, spot drilling or center punching is a great way to establish a guide hole that a longer drill will later follow without wandering off location. After all spot drilling is complete, we will then move to our third operation of drilling 4 perimeter holes. Our selected tool for this operation is tool number 7. We will use a 1/2 inch diameter drill bit to drill through on our 4 previously spot drilled perimeter locations. Our fourth operation will be a simple drilling in the center of the part to a specified depth using the same tool 7. This will be our pilot hole for the pocket milling operation coming later. After all drilling has been completed, our fifth operation is to custom profile the outside. Our selected tool for this operation is tool number 2. We will use a 1/2 inch diameter end mill with flute length of 1 inch. This operation will require the use of the Fagor profile editor to solve complex and missing geometry not given on our demo part print. Multiple depths of cuts will be required to complete this machining operation. After completing the profile, our sixth and final operation will be to mill the center pocket to length, width, depth, using the same tool number 2. This pocket operation will perform multiple step-over passes to clear the area as defined by our program. This concludes our preview of the machining operations, tools, and programming steps we will be using in this video. Please feel free to rewind, pause, and review the previous information as needed before advancing further in this demo video. It is now time for us to do our machine setup. We will start with the calibrating of our X and Y axes part 0. In our example, we will use an edge finder with a stylus radius of 200 thousandths of an inch. Press the Escape key until we are on the main menu screen. Let's calibrate the X-axis first. Using the jog key or the hand wheel, jog the X-axis until you touch the part. Once the tool has made contact with the workpiece, press the X-axis key. Then type the radius of the tool as a plus or minus distance so the current tool's center is the proper distance from X0. In our example, we will type negative 200 thousandths of an inch and press Enter to activate the new X-axis part 0. To calibrate the Y-axis, jog the Y-axis until you touch the part. Once the tool has made contact with the workpiece, press the Y key. Then type the radius of the tool as a plus or minus distance so the current tool's center is the proper distance from Y0. In our example, we will type positive 200 thousandths of an inch and press Enter to activate the new Y-axis part 0. The final machine setup step is to calibrate the tool. In our example, we will calibrate tool number 1. Press the tool calibration key. Select the tool you want to calibrate by pressing the T key followed by the tool number 1, and press the cycle start button to execute. The axes should now move to the tool change position. The CNC will dwell and wait for you to finish the tool change. When done, confirm the tool change is complete by again pressing the cycle start button. The CNC now updates the active tool on screen and we can continue. Next, using the jog keys or the hand wheel, jog tool number 1 to the top of the part surface. Once touching the top of the part, press the Z key, followed by the Enter key. The CNC will measure and update the L value on the control. L is the tool length. K is equal to any tool wear. At this time, there's no need to define K, arrow down to continue. R is the radius of the tool. In this example, tool 1 has a radius of 0.5 inch. I is any radius wear on the tool. At this time, we will leave it blank. The bottom half of the screen does not have to be defined at this time. To confirm that we have done a proper machine setup and everything has been calibrated correctly, jog the Z-axis up until we are clear of the part. Now press the ISO key. Type X0, Y0, and press cycle start. The X and the Y axis will now move to the part 0. Now turn down the feed rate override to 0% and again press the ISO key. Type Z0 and press the cycle start. At this time, slowly turn up the feed rate override switch to approach the part surface with the tool. Note, please stop the command at any time by pressing cycle stop or returning the feed rate override switch back to 0 if tool collision with the workpiece is detected. If the tool length was calibrated correctly, it should look like this. We will now save the part 0 to our 0 offset table. From the main menu, press the reference key twice to bring up the table. Select the G54 offset using the up and down arrows. Press Recall to update the table. Press Enter to save and activate the G54 offset data. Note, in most machine setups, tools will have different calibrated lengths, but will all share the same common X and Y part 0 that you have already established. Press Escape to go back to the main menu. In this section, we will show you how to cancel and recover tool offsets. To cancel a tool offset, from the main menu, press the ISO key. Type G53 and press cycle start. You will notice that the large axis coordinates and the small axis coordinates match. This shows all offsets have been canceled, as part 0 and machine 0 are the same values. To recover the part 0 you previously established, go back to the ISO mode, type G54 and press cycle start. This will again activate our G54 offsets that were previously established earlier in our machine setup.